Hi everyone. I'm talking today about how do we improve cybersecurity labs by measuring human performance. And this is based off of a paper that I submitted to the iConference, and they looked at it and they said, nah, we want a little bit more out of a short paper. We want actual data and publication and outcomes. And I said, okay, fine. It's okay, because we're not quite there yet. And you'll see a little bit of that as I present here today. This is going to turn into a paper for the NSA Centers for Academic Excellence in Cybersecurity, the Community Symposium in the spring. So I have a feeling that they're going to look at it and go, oh yes, this is right up our alley, because it's all about cybersecurity and labs. This is based on some work that I'm doing with my PhD student, Jim Mayberry, and two of our master's students, Drupad Joshi and Rishikesh Galande. The three of them and I are in a lab together to do cybersecurity education-related work. So thank you for inviting me to do this, but who am I? Yes, hi everybody, I'm Nick. I'm that annoying person that you guys are like, oh Nick, will you please just stop? So you know that I'm a teaching faculty member here in the college, and I teach cybersecurity courses. I'm also our program coordinator, and I think, we have to verify this, that we are the largest resident cybersecurity undergraduate program in the United States. So it's a question of like who's actually publishes their numbers, et cetera, et cetera, et cetera. But we're certainly up there in the top few large programs.
One of the largest.
One of the largest. Well, we can make that claim, absolutely. I like to work with our tenure track and teaching track faculty partners, both here at University Park and across the Commonwealth, to make sure that we're doing a good job of how do we teach cybersecurity for these students as they go off to their lives and careers. I'm our point of contact for the NSA CIE and cyber defense for Penn State. Means I go to all of our annual meetings and hear from our colleagues from across the 550 institutions that all do cybersecurity at that level. And I'm a co-PI along with Dong Wan and Kathleen Moore in some scholarship programs connecting our students to federal government jobs and jobs in the Department of Defense. But yes, I teach cybersecurity courses, and I want to teach cyber courses better than what we do today. And my students, they're not learning as much as I want them to. And they don't seem to retain the information that I'd hoped that they would retain, especially after they do these practical lab exercises, which we're expected to do in our program. It's a core component of what we do in cybersecurity. And I look back at what I've done in terms of my development to get to the point where I am now, and I look back when I did my PhD here in the college, and I'm one of these crazy, weird, interdisciplinary scientists. I have a background that's in the technology-related stuff and in cyber-related stuff, but I also have this little component of cognitive science. I worked with Mike McNeese and Dave Hall and got a little orientation to human cognition and how do you measure human cognition in cybersecurity and what does that even mean? And that folds in really nicely to what I do as an educator. How do I do this human cognition measurement in my students to measure did the stuff get to where it was supposed to get to? How do I measure and assess that? I think we suffer from what I call the I touched it once problem. Our students go and they do the lab and they do the thing, they type the command, they press the button, they do exactly what we tell them to do. Only the things that we tell them to do and don't do anything more than that because they're cognitive and temporal misers. They're only going to spend as much time and cognitive effort as is minimally required to get the immediate goal out of doing the thing. Okay, I did the thing, I did the lab, and I turned the thing in, and immediately afterwards they brain dump it. They don't go back and do the lab a second time. They don't do it a third time and a fourth time. They don't build up their cyber muscle memory. I want them to be that student there on the left side where they're like, I did it again and again and again, and I really know and I really understand that. But instead I get the student on the right side who's like, oh, well, I have to do the thing, and you make me do the thing, and I'm gonna do it with as little brain power as is required, with as little time as required. They're going to find the shortcut to do that. Now, not all of my students are gonna do that, but I think the bulk of the majority are going to give that minimal effort. And they're not going to build the cyber muscle memory the way I want them to. So I'm going to talk a bit about some of the challenges we have in cyber labs, our lab platform developments that have happened over time. Think about some new considerations for how do we design better labs and look at these cognitive assessment kinds of efforts. And I'll talk about some of the work that my lab team and I are doing in the next semester that was interesting. I mentioned that hands-on labs are central to cybersecurity education across all those institutions that do cyber education across the United States. We all have the same kinds of problems. Those problems are things like the high cost of implementing these hands-on lab experiences, the faculty burden of doing this, and the student response is sometimes in this category of, well, we'll call it cheating, but certainly like cheating themselves out of that experience and the learning that they should be having. The lack of retention is a big issue. So there are 4 stakeholders in cybersecurity lab related stuff. They're the students, the institutions, the faculty members, and their future employers. And there's a new stakeholder that's in the middle of all this, the developers of lab platforms that are often tied to textbook publishers that are selling their wares to all of us, to all the faculty. So, that's a challenge as they do what they're doing to meet what their goals and objectives are, trying to meet what they think our goals and objectives are. The students, we want them to minimize their cognitive overhead. How much brain power does it take them to do the thing to hit the actual learning objective that we want them to hit? I want them to have what I call meaningful repetition. Not just blind repetition of doing the exact same thing the exact same way and getting the exact same result that you got the last time that you did the lab, but do it again and again and again in meaningfully different ways so that they can say, oh yeah, no, after the 4th time I did it, I finally got it. And it is the learning objective, the thing that I want them to learn in terms of the objective of what comes out of that course. Our institution has other needs. And those needs are things like, well, we want low costs and a sustainable infrastructure and a scalable infrastructure that I can scale from just a class of say 10 or 12 or 15 students that I might get at one of our campuses all the way up to, I don't know, 150 students, 200 students, 500 students in a large section course. Our institution doesn't want to spend hundreds of thousands of dollars, literally, we used to do this here at Penn State, in the College of IST, for our virtual hands-on lab system that students like pressed a button and typed a command that we told them to type. They got kind of dumb outcomes. And it's because we were like throwing lots of money at infrastructure that wasn't really getting us to our goals. Faculty members, those of us here in the room, those of us I'm going to talk to in the spring across the country, we have limited time to develop new labs. I want to spend all of my time developing the new lab, but I don't have that much time to do that. I need to be able to automate the grading process and do more than just, okay, did you complete all the steps of the lab, but do that, like, did they actually hit the learning objectives in the way that I want them to do? And when I get larger and larger sections, that gets more needs for automation, et cetera, et cetera, et cetera. So those are some of my expectations. Our employers have other expectations. They want the student to have mastery of the KSAs, the knowledge, the skills, the abilities to do the work. And these are referenced in some frameworks like the NICE framework, which is the National Institute for Cyber Education, part of NIST, that has boiled down jobs and classifications across the government that are cyber related into specific lists of knowledge items, skill items, and ability items. So in the defense environment, by the way, the NICE framework has 52 different cybersecurity workforce roles. The defense version of that has 72 different cybersecurity workforce roles. And each one of those roles has a list of a couple dozen KSAs. I'm stuck in the vicious cycle of lab platforms. And those lab platforms, when we started the College of IST, we had a whole room of computers and stuff and switches and network devices we could plug in. Students would come in and get their hands dirty with stuff. But that didn't scale. And we started doing things with virtual machines, with VMware and VirtualBox and Hyper-V and all kinds of stuff. And that turns into a certain set of pain points about how do I make that work on the student's machine. We've built out racks upon racks in the data center downstairs of type 1 hypervisors to give students lab exercises, and literally it turned into a giant pile of money that the college hated to spend. We're now working with these third-party vendors to provide lab access on their systems in the cloud to do some things, but that turns into just a money problem for students. And I'm looking at things now with browser-based virtual machines. I don't know if we can even see that. Yeah, that's not too bad. In a very thin way of giving a virtual machine access to a student where it doesn't cost back-end infrastructure implementation costs. In all of these, I deal with hardware inconsistencies. If I've got students who have Macs versus PCs versus old machines versus one that only has 4 gigs of memory on it, or 16 or 32 gigs, and it doesn't work all that well. The setup complexity to do this, Matt Ruff and I are working on how do we do this in a more effective way, and he's spending a lot of his time babysitting students to set up hypervisors, and it's just painful. The cost and maintenance, if we do it at the institution side, the scalability limitations, or even our third-party platform companies are saying, hey, you know, we're going to do this, and we say, okay, I have 150 students that are all going to press go now, and we crash their system. Literally, this is what's happening to us, and it is nothing but pain. As we go to do these new implementations, I've tried to do things to reduce setup tasks. I had an early lab that I did a few years ago. It's like, okay, you need to learn Linux and Linux commands. And in order to learn the Linux commands you're supposed to learn, I said, okay, first what you do is install a hypervisor. And then inside your hypervisor, install a virtual machine of Ubuntu Linux, you know, 2204, whatever it is, and get that running. And then install a whole bunch of dependencies like Git and a whole bunch of other commands you have to go and get that to install and get that to run. And then clone my repo off of GitHub and put that on your system and execute the thing so that you can learn how to do CD and LS. I'm like, if you needed to learn how to do those, you couldn't do the prerequisites, right? We get into what's referred to as task exhaustion, the setup exhaustion of getting the whole thing set up. It would take an hour to go set up the whole thing to do a 15-minute little exercise that we had everything out of order. But we need to focus on those learning objectives and reduce the overhead. All that's great. All that's lovely. That's the normal stuff that me and my colleagues from across the country are doing. But it's not enough. And it's not enough because we all build the same lab or the same thing. We share it back and forth. We go buy it from the third-party vendor. And everybody does the thing and presses the button and types the command. We need to design lab activities that have meaningful repeatability so that the task gets done again and again and again in different contexts. So if you're setting up a SSL on a web server, we don't set it up for webserver.com. We need to set it up for this server and that server and that server. And sometime between 2 and 10,000 iterations, it's going to sink in for the student. The question is, how many times does it take? But we need to balance that repetition with those diminishing returns. How can we make that happen? So we're doing some stuff now in parameterization, putting parameters into the exercise so that we can alter things like IP addresses and host names and configuration, so that when I give that exercise to one student and they do the exercise, they can't take those answers and give it to their friend sitting right next to them because their friend has their own parameters. So I've been doing work on how do I prevent the copy-paste cheating problem. But that also leads us to meaningful repetition, because if I can do it once different for every single student, I can also say, well, then the first time you do it, you get one set of parameters. The second time you do it, you get a different set of parameters. The third time you do it, you get a different set of parameters. And that leads to per student variability and per attempt variability. So students can do things again and again and again and again. How do you measure achievement? Right now, the lab platform that we're using does a really great job of saying the student progressed through a certain percentage of the lab. But that leads us to completion-based assessment. You completed 75% of the lab, here's 75% of the grade. You completed 100% of the lab, here's 100% of the grade. But did you learn anything? I don't know. And that makes me frustrated. We need to evaluate retention and recall. How can we measure, did the student get the right answer after they did it 2 or 3 or 4 or 5 different times, so we know that it actually stuck there, so when they show up to the job interview and they show up to the competency-based interview assessment, that they can do the thing. Not just that they say, oh, I did a lab about such and such in college. In the NSA CAE community, we have Vinnie Nestler and Zoe Fowler have pushed forward an assessment model, the ABCDE assessment model, where the actor, the student, has a certain behavior, they can do the thing, in a certain context, in the work kind of environment, to a certain degree of capacity that matches with an employability outcome. We're expected as an institution in the CAE community to measure and assess our learning objectives using this model. And today, I don't think anyone across the country can measure and assess to the certain degree of competence and to match with the employability. We all say that we're doing it, but we're not actually nailing down what we're actually doing. So in terms of some future work, our lab team is looking at how do you measure retention and engagement in these kinds of labs. We want the student to want to do the task more than once, but do they actually do it more than once? As we build engaging mechanisms to get them to want to do it, we need to measure, do they actually make that happen or not? Do they do the lab multiple times? Measuring retention is after this spaced out repeated engagement. How many times do they have to do that over what period of time before we can say, after they've done that, we can then test to see if it actually stuck? Can they do the task at the beginning of the whole 2-week exercise, for example, and we measure their time of doing the task, and when they do it a couple of weeks later, after having done it 2, 3, 4, 5, 6, half a dozen different times throughout that time frame, do they do it faster when they come back into the lab a second time around? So how much repetition is enough? So we have 3 different projects that we're working on with 3 of my students. Jim Mayberry is a PhD student who's working with us for the next couple of years. He's here as part of a sponsored program with the United States Army. After he's done here, he goes off to West Point to go teach cyber. And so we're gonna run a study in the spring with a learning Linux exercise, measuring student retention in that kind of exercise. How much do they remember after they do it 2, 3, 4 times? So measuring the retention and measuring the repetition. Did they actually do it? One of my master's students, Drupad Joshi, is developing a thing to reduce the overhead in some of these Linux cybersecurity lab experiences. He's doing it with a browser-based virtual machine. He spent a bit of time installing Arch Linux in a browser-only environment. So the Linux machine runs inside the web browser. It doesn't have a back-end hypervisor. So we reduce our overhead costs. And doing that between multiple machines. So we have multiple machines, so we can have an attacker machine and a victim machine, all running inside of your own browser of your own computer or the student's browser. And Rishi Galande is working on an intrusion detection exercise where he's doing more than just ping. Intrusion detection is supposed to be able to detect misbehaviors going across networks with tools like Snort and Bro and many others. And he's doing some pseudo-random variation with different IP addresses being the attackers. Where is the attack coming from? So different students would get different attacker IP addresses and different payloads. So what type of attack was it? So that the student can get one exercise and the next exercise and the next exercise. It all gets to be different, and then different between different students as well. So that's what I'm up to, and I think I've probably hit close to time. Maybe you have a couple minutes for a couple of questions.
Do you know if there is any study on the effectiveness of meaningful repetition?
As applied to cybersecurity labs?
Yeah,
Absolutely not.
there's nothing.
No, there's, as far as I can tell across industry, and this is where Jim Mayberry is doing his literature review work now, we see a lot of, hey, I built this cool lab, and hey, the students seem to like it, therefore it is good. Nobody is measuring, did they remember and learn the things they were supposed to do? There are studies in education about spaced repetition. If you do things over periods of time, it sticks in your brain. I know that from being a little bit of a cognitive scientist. I know that short-term memory holds between 5 and 7 things, and you get rid of it as soon as you're done using it. But if you do it again and again and again, it builds up schema in long-term memory. So if we do the spaced repetition, we know from the education space that we're supposed to get outcomes like longer-term retention, right? But nobody's studied it in cybersecurity labs across the whole industry. All those 550 institutions, all those lab developers, nobody's doing that.
Thank you.
Thanks, Nick. You probably do mean this, but do you think about it as scaffolding? So for when I was teaching GIS and cartography, I would start them with a lab that had simple stuff, and then the next lab would expect them to bring that to the next lab and not re-explain it. So project your data or whatever.
Can you come to our faculty meeting with our department and help us to realize that we need to do that, not just from inside of one course, but from one course to the next? Absolutely, we need to do that kind of work, and I don't know if we're great at it.
Well, and you talked about repeating the lab, but I think that you maybe use the early labs in the later labs.
Oh, no, I actually do mean almost identical repetition in certain cases. Within that lab experience. But yes, going from the one to the next is also useful. And so that scaffolding and stacking from one to the next is, do you happen to have a citation of where that comes from? So I'd love to.
Exactly.
All right, well, I think we're about there, right?
Yeah, just quick, one more question. Sure. So if you go back, you have the 3 students working on kind of 3 different projects. I would say the master students are both developing labs or exercises.
A single exercise.
A single
yes.
exercise. And those are outside of the platforms that you were talking about, or are they within the platforms?
Both of those are going to be within let me go back to okay, so if these different platforms that are out there,
Yeah.
both of those are in browser-based virtual machines in that top left corner.
Okay.
But they could also be done on local hypervisors in local machines and could be implemented in a variety of different platforms, right? But
Right.
the question is, like, how do we make it meaningfully repeatable?
Right,
Is a big piece of
right.
that.
And then as you know, sometimes we talk about, research project management and then group management. If you look at these 3 students' projects, are there kind of lessons that can be drawn amongst them together collectively so that what you're talking about is some research outcomes for each project individually, but then together as an overarching investigation into like cybersecurity education in a more narrow.
Right, and I think each one of these students is attacking a different part of that bigger problem. Yeah. Jim's attacking the question of the cognitive measurement at the moment. Yeah. But he's going to end up developing his own set of lab exercises to then go turn around and measure. What Drupad is doing is he's reducing the speed bump. Yeah. And what Rishi is doing is he's doing the meaningful repeatability calculation process, and they all fit in the grander scheme. Yeah. Now, what Rishi and Drupad are doing, they're going to end up doing a small user study, like get a group of friends and go test out their lab, and they might do some little bit of the cognitive measurement too, but that's more of what Jim's doing in the larger study.
Yeah, I'm just thinking like Jim could be involved in those master students to kind of bring them all together.
Absolutely.
Yeah.
And Drupad and Rishi are both graduating here this spring,
Yeah.
so Jim might end up doing that with the next round of master
Yeah,
students.
yeah,
Right,
exactly,
Absolutely.
exactly. Great,
All right,
thank you
well,
so
thank
much.
you, everyone.